In today's lesson, we are seeing how we can move the graph of a quadratic function from side to side. And this happens when you introduce the middle term. This looks familiar because we've already learned how to factor these types of quadratics, where now we're going to graph them. So our steps change because instead of the vertex being somewhere on the y-axis, instead of the vertex always being at the origin or being a translation up or down, now the vertex can move from side to side. So what we do is we take the values a, b, and c, and in particular just b and a, and we plug it into this formula. This formula that I just circled, you might want to highlight it or circle it with your paper, put a star by it, something. If you take the coefficient of x and then divide it by twice the coefficient of a, and then take its opposite, that will be the x-coordinate of the vertex. The way you get the y-coordinate is you'll plug the x-coordinate into the quadratic function. So let's write that down. So you get the x-coordinate by plugging it into this relationship. And then to get the y-coordinate, you're going to plug x-coordinate of vertex into function. And then after that, it really doesn't change the form. The format doesn't change that much. So the three steps is first to calculate and plot the vertex. After that, you calculate the delta y pattern. And then after you calculate the delta y pattern, meaning there is no coefficient of x squared, it's just the 1, 3, 5, etc., right? But you might have to go a times 1, a times 3, a times 5. Just like we did yesterday. So that step is really no different. And then the last step is also not different. You're going to go ahead and draw the axis of symmetry. And reflect the points. And this will all be clear once we start doing an example. Just get these steps down so that you have something to reference tonight when you're doing your homework at home. Okay, let's go ahead and look at the first example. Your directions say make a graph of the following function, state the vertex, the axis of symmetry, and the delta y pattern. Well, our step one in our, that we just listed was to find the vertex. So we're going to take this formula, and I say x equals the opposite of b over 2a. Now, where the negative sign is doesn't really matter. If you ends up with two negatives somewhere in the fraction, you know the whole fraction is positive. So who could tell me what the value of b is for this function? Tate.
-2.
Yes, for this function the value of b is -2, and then the value of a? 1. Everybody understand how I got the value of a and the value of b? I would like to see some hands. Megan, where did I lose you? All right, so we always compare it to this formula. Okay, so the coefficient of x squared is a. In this case, x squared's coefficient is 1. And the coefficient of x is b. You guys have seen this. We used this terminology when we factored. Remember I said, what are the factors of c that add to b? Or the factors of a and c, and we check our smiles. So in that respect, it's not a different formula. So any questions now on how I got b and how I got a? Yes, Aaron?
If b on the equation, b is a -2.
On the equation, so yeah, I have -2 right here. All right, because this says plus, and so since this is a -2, we have to make b value of -2. Alright, so now we're going to plug these values into the formula for finding the vertex. So it's going to be x equals negative sign from the formula, negative sign from negative 2, all over 2 times 1. And where you place the negative signs, like I said, doesn't really matter. If you have it on the outside, it's fine. Remember that if you just have an even number of negative signs total, then the whole value will end up being positive. So here I have even number of negative signs, so really it's just 2 over 2 times 1 is 2. So what's the x-coordinate of my vertex? 1. Great, so we're halfway there on the vertex. The x-coordinate is 1. The way you find the y-coordinate is you plug x into the function. So my function is here, right? So I'm going to say that y equals 1 squared minus 2 times 1 minus 3. Now students always tell me, well, can I do that in my head? Sure, but you run the risk of making an integer's error, and I always recommend that you write it down. But it is your gamble, all right? So we're going to follow order of operations and square the 1. 2 times 1 is 2 minus 3. This one's a really easy one. Now we're going to make sure we subtract going from left to right. 1 minus 2 minus 3 negative 4. So now my vertex, and we have to label this because it's part of our answer, is to say 1, negative 4. That's going to be our starting point. Any questions on how I found the coordinates of the vertex? Great. Let's go ahead and plot the vertex. Over 1, down 4. And then the next step said to calculate the delta y pattern. You guys, is there a value of a that changes our delta y pattern in this example? No, a is 1, right? So our delta y pattern is going to be 1, 3, 5, 7, right? So let's go ahead and do that. From our vertex, and it's positive, right? We don't have to think about multiplying by negative. Over 1, up 1. Over 1, up 1, 2, 3. And then I don't think I can go up 5. I can go up 5. Over 1, up 5. So that's it. Then it said to draw the axis of symmetry. Axis of symmetry is going to be that vertical line through the vertex, right? Now I have another color I can use, so I'm going to do that. Here's my axis of symmetry. Who can go ahead and tell me the equation of my axis of symmetry? Anybody know how to write the equation of a vertical line? Eli. X equals 1. You guys, it's always x equals the x-coordinate of the vertex for the axis of symmetry. So we have lots of things going on. I have a delta y pattern part of my answer. I have a vertex part of my answer. I have the equation of the axis of symmetry. And I still need to reflect the points, right? So I need to reflect them on this side so that you have your complete parabola. Questions on how I got this? The vertex is part of the answer. The graph is part of the answer. The delta y pattern and the axis of symmetry. A lot of parts to one problem. Okay, you guys, let's go ahead and do the next one. So step 1 says calculate and plot the vertex. So go ahead and tell me what A equals and what B equals and plug it into this formula. Go ahead, Evan. What was your question?
Oh, I was going to ask, how did you get the change in y?
Remember that we learned from Friday that for a quadratic function, it's always 1, 3, 5.
Yeah, but why'd you, it's changed in y, why'd you plug in a for that?
I plugged in A.
Is that just how it goes?
It's always 1, 3, 5 for when A equals 1. And then if A has a value of like 2 or 3, if there is a coefficient of x squared, then we multiply 1, 3, 5 by that value, which we did not have to do in that question. All right, so who has calculated, or who can tell me what A and B are? Michaela?
A is negative 2 and B is 12.
Good. So now let's plug that into our vertex formula. We're going to have negative 12 over 2 times negative 2. Now I have negative 12 over negative 4. And the x-coordinate of the vertex is? 3. Now we need to plug it in and watch your order of operations. Negative 2, 3 squared, plus 12 times 3 minus 11. So follow order of operations. 3 squared is 9. 9 times negative 2 is negative 18. 12 times 3, 36. Minus 11. Make sure you do your addition from left to right. We're going to do this one first. Negative 18 plus 36 is positive 18. Make sure you're doing this with me and not just writing things down after I write it down. Try to calculate, be one step ahead. And then 18 minus 11? Nice. So let's go ahead and label our vertex. Vertex is 3, 7. And after you calculate the vertex, you plot the vertex. So you're going to go over 3 and up 7. First step. Because your delta y's come from the vertex. You have to have the vertex before you can do anything else. Alright, now we have an a value this time, right? So our delta y pattern, we're going to have to go negative 2 times 1, negative 2 times 3, negative 2 times 5, and if we have room, negative 2 times 7, which I don't think we will have room for. So our delta y pattern is what? Negative 2, negative 6, negative 10, negative 14, etc. So we always go over 1 for every for the change in x. Over 1, and instead of down 1, we're going to go down 2. Then we're going to go over 1, and then we're going to go down how many? 1, 2, 3, 4, 5, 6. And then we're going to go over 1 and then down 10. So there's that half of my parabola. I'm going to go ahead and change colors and graph my axis of symmetry. Who can tell me my equation of my axis of symmetry? Kevin. X equals 3. It's always x equals the coordinate of the x-coordinate of the vertex. Alright, go ahead and reflect the points. And finish your parabola. And all of this is part of your answer. You got to put a box around that. Your axis of symmetry, your delta y pattern. All of that is part of your answer. Any questions on how I did that one? Okay. If you're finished with number 2, I'd like you to turn the page and start number 3. See, A is going to be positive 1/2. B is positive 4. X equals negative b over 2a. X coordinate of the vertex formula. Negative b would be negative 4. And then 2 times 1/2 is 1. So our x coordinate of our vertex is negative 4. Let's go ahead and plug it in. Y equals 1/2. Negative 4 squared plus 4 times negative 4 plus 3. I strongly advocate that you write it out. Follow order of operations. You have to square this first. And when you square a negative number, it's going to be a positive number. So what's half of 16?
8.
Alright, now 4 times negative 4 is negative 16. Let's add things up from left to right. Alright, so then I have 8 plus 16, negative 16 rather. Negative 8 plus 3, negative 5. So our vertex is negative 4, negative 5. Go ahead and plot it. And let's calculate our delta y pattern. We have an a value of 1/2, so we're going to have to multiply 1357 by 1/2. So 1/2 times 1, 1/2 times 3, oops, 1/2 times 5, 1/2 times 7, etc. Okay, so then from our vertex, we're going to go over 1 up 1/2, over 1 up 1 1/2, over 1 up 2 1/2, over 1 up the half, and then 1, 2, 3. Ooh, I have more to do. Well, it fits. 9 times 1/2 is 4 1/2. Will 4 1/2 fit?
No.
No, it won't. Okay. So we try. Go ahead and connect your dots. And notice how I had my last point was right there, but my graph didn't get much wider. Okay? If you can see, my last point was like right here, right? Something like right there. And I was careful that when I drew my line, I didn't go crazy out here. I made sure that it didn't get further than the continuation of this next line over. Okay, go ahead and write your axis of symmetry. And Coleman, what's my formula or my equation of my axis of symmetry? Well, that's okay. So what is it though? We've already found it. -4. We've already calculated the x-coordinate of our vertex, and remember that the axis of symmetry is really just x equals the x-coordinate of the axis of the vertex. I see that. All right. Once you have that graph and you've labeled it, go ahead and reflect your points. A bit like that. Oops, I went crazy with that one. Crazy. All right, I would like you to go ahead and try number 4 by yourself.